So previously we talked about the atom and what the atom looks like and subatomic particles that are involved inside the atom. So before we start taking notes, I want you to look at the sheet in your notes. It's called Changing an Atom. It says what's the matter up at the top. I want you to think about, kind of reflect to yourself of what happens to an atom as each one of those things takes place. And I want you to write those words, those new vocabulary words that we have in each of the circles as prompted. Then once you've done so, you can come back to the video. We're going to start talking about the Bohr atom. So the Bohr atom, as you can see, is using the planetary model. Planetary model, which we've talked about from Niels Bohr, hence the Bohr model or Bohr atom. And we're going to talk about what each orbital can contain. So when we use the word N is talking about the principal energy level. Each electron on a principal energy level has a specific amount of energy. We know that there's actually going to be 7 of these in total. So when we look at these energy levels. The biggest thing that we're going to start looking at in regards to this is the maximum level or the maximum number of electrons on each energy level. So looking at the first level, which is the inside level here, can have a maximum of 2 electrons. The second can have 8. The third can have 18. The fourth can have 32. And the 5th through 7th, we're honestly not even going to worry about because it gets a little crazy after that. So most of the time, actually 99.9% of the time, this is what New York State looks at. The first 4 principal energy levels and the amount of electrons controlled, or I shouldn't say controlled, but that are on or capable of having that many electrons. So we're going to look at what's called electron configurations. And electron configurations is actually the arrangement of electrons in each ring, which is actually given to you right in your reference. So if I were to give you something like 2-8 as a valence electron, or sorry, as your electron configuration, you know that there are 2 electrons in the first principal energy level, and there are 8 valence electrons in the second principal energy level. Which goes back to the next term, valence electrons. Valence electrons are the outermost electrons. They are electrons in the outermost shell. So in this case, my outermost would be my second principal energy level. So these would be what's known as my valence electrons. In this case, I would have 8 valence electrons. So Bohr model and electron states. So I want you to think about drawing the Bohr model for iron, Fe. I want you to include the nucleus, the electrons, the number of protons, and how many principal energy levels are there. So as we look at Fe, we can see the atomic number. And the atomic number we know is 26. Well, what does that 26 tell us? We need to remember that 26 stands for the number of protons. And where are the protons located? They're located in the nucleus. So as we draw this, we need to make sure that we have 26 protons in the nucleus. In this case, you can just put 26p. Then the next thing I have to figure out is how many neutrons are found inside of the nucleus. Well, 55, I'm going to round that to a nice 56, because you can't have half a neutron, so we're going to have 56. 56 minus 26 gives us 30 neutrons. So there's my nucleus all put back together. Now the next part is actually a little bit of the easier part. You're going to look at the electron configuration right here, and you can see that it's 2, 8, 14, 2. How many principal energy levels? 1, 2, 3, 4 principal energy levels, so 4 orbitals. On the first one, I'm going to have 2 electrons. On the second, I'm going to have 8. On the third, 14. And on the last one, 2. So how many occupied energy levels are there? You're just going to count the number of groups. 1, 2, 3, 4. So you know you're going to have, 4 altogether. Which electrons have the lowest energy? So when we talked about principal energy levels, principal energy number 1 or principal energy number 4, which one of those has the highest value? So number 1 has the lowest, so the lowest energy is going to be the one on principal energy level number 1. And the highest amount of energy is going to be on principal energy level number 4. Think about it in this way. The farther you are from something you're attracted to, the harder you have to be attracted to it. Think about being in a relationship. If you're in a relationship with somebody else and you live really close together, it's not as hard to make the relationship work. However, if you're very far apart from the person you're in a relationship with, it is much harder to be together. So you have to put more energy in to make the relationship work. So how many valence electrons is the last question? Looking for the outermost electrons, so the outermost here being 2. We look at the Bohr model. Okay, what we're going to look at is the electronic states. So what I want you to do is write the electron configuration of the following atoms, and then state how many principal energy levels each element has. So you're going to use your reference table, and you're going to find each one of these on your reference table. And I want you to write in the electron configuration and tell me the number of principal energy levels. So as you look at the first one, you know neon 2-8 gives you 2 principal energy levels. Strontium 2-8-18-8-2, so 5 principal energy levels. Bromine has 2-8-18-7, so 4 principal energy levels. Magnesium's 2-8-2, 3 principal energy levels. And copper 2-8-18-1 with 4 principal energy levels. And again, looking at this, we know the valence electrons that are found here are going to be on the outermost shell or orbital, which is the last ones in the sequence. So draw a Bohr model for each of the following neutral atoms. So neutral atoms, we know that they're going to have the same number of protons as they do electrons using the electron configurations on the periodic table. So we're going to look at the following. I already gave you the orbitals. Okay, and as you look at lithium, we look at the electron configuration for lithium, we know that's 2-1. So how many electrons on the first one? 1, 2, and 1 on the second. Protons, you know there's going to be 3 protons. Neutrons, you know there's going to be 4 neutrons. Oxygen, we know is going to be 2-6. In the nucleus, we're going to have 8 protons. We're going to have 8 neutrons. First principal energy level here, we're going to have 2. Second principal energy level, we're going to have 6. 1, 2, 3, 4, 5, 6. Okay, the E's or the electrons, doesn't matter where you put them as long as they are the correct number on each orbital. Next one we have is argon. We're going to have 2-8-8. So inside of the nucleus we have 18 protons, and then we have 22 neutrons. And on the first principal energy level, we're going to have 2 electrons. And on the second, we're going to have 8. 1, 2, 3, 4, 5, 6, 7, 8. And on the last, we're going to have 8. So 1, 2, 3, 4, 5, 6, 7, 8. Again, it doesn't matter the location of the electrons because, if we remember correctly, this isn't the actual location. Remember, these electrons are constantly in motion. That's why we use the wave mechanical model to show the location or the probable location of each of those electrons. Helium, as you go through, helium, you got to think of helium. How many electrons are in helium? Oh, there's just 2 electrons in helium. So since there's just 2, think about how many protons are in the nucleus and how many are on that first principal energy level. Well, helium has a mass of 4, an atomic number of 2, so we know it's 2 and 2, and electrons we have 1, 2. Chlorine, we look at chlorine, we have a 2-8-7 electron configuration. We have a total of 17 protons. We have 18 neutrons. On the first principal energy level, we know we have 2 electrons. On the second, we're going to have 8 electrons. And on the third, we're going to have 7 electrons. So again, using these symbols are so useful, especially for new chemistry students. Look at all the information that's here. You can see the atomic mass. You can see the atomic number. You can see the electron configuration. And then later on in the school year, we're going to talk about these numbers right here. These numbers right here are the common ions that appear. Not all the ions of these elements, but the most common ions that these ones will form. So you can see that chlorine typically forms a -1 ion. We'll talk later on why that is so important. So back to electron configurations, we're just going to copy this down. We have 2-8-7. Number of occupied levels we know is going to be 3. 1, 2, 3. Valence electrons. So when we look at valence electrons, we have 7 valence electrons. Excited configuration. So excited configuration is where an electron gains more energy. And we said that the low amount of energy is on the inside towards the nucleus. And we said that the farther away you get away from the nucleus, the higher your energy is going to be. So if you're excited, you have more energy. So that means an electron is going to move away. So you have what's called an incomplete fill order. So in this case, you could have 2, not 2-8, but 2-7-8, or you could even have a 2-8-6-1 configuration. We got silver configuration we know is 2-8-18-18-1. Occupied levels 1, 2, 3, 4, 5. Valence electrons is just 1. Excited level 2-8-18-17-2. Multiple excited states for this since it is so large. However, you need to make sure if this is a neutral atom, not an ion, you have the correct numbers of electrons as you do that of your protons. Last one, Ra. Ra has a dash in front of it. What's that dash mean? If you look at the bottom of your periodic table, that means that there's a 2-8 preceding. So 2-8-18, 32, 18, 8, and 2. 7 occupied levels, 2 valence electrons at the end. And again, you could have a whole lot of excited state configurations, but I'm just going to take the last one. So dash 18 dash 32 dash 18 dash 7 dash 3. I apologize. That's 7 there. Again, multiple answers you could have had for that last question there. So, ground state versus excited states. When you look at ground states versus excited states, ground states are all electrons are in their lowest possible state. This is still a neutral atom. This is exactly how you see it on the periodic table. Excited state is when an electron is moved to a higher principal energy level. Still neutral, but has an excited electron. Same amount of electrons, but not the same order as what you would see it on the periodic table. So 2 plus 8 plus 2 gives you 12. 7 plus 3 plus 2 still gives you 12, but you can see that this order is not the same as that which is found on the periodic table. So next thing we're going to talk about is excited versus ground, and how do you go from excited to ground, or from ground to excited state.